Hi, I'm Ike Ellis. Now we're going to prepare to migrate an on-premise SQL Server to Azure. We're not actually going to do the migration, that will be the next video, but we have some steps that we have to accomplish before we're ready to do the migration. For instance, when we have our on-premise SQL Server, we should actually do real work now. We're not just planning, we're not just talking about Azure concepts, we're actually doing real work. First, we need to pay off some technical debt. There's some things that we can do to make this migration very easy if we implement some best practices into SQL right now. We need to make the database smaller, for instance. We also need to figure out networking. How does our on-premise data center actually connect to Azure? We need to think about security and Active Directory, and then we need to do some work in creating the VMs and making sure that our VMs are the right size and that they're configured correctly. And then finally, we need to do some baselining and performance tuning. And then I'll demo some things that we can do to make to assess that we did these things correctly. So, like I said, first we need to pay off some technical debt. One thing that we can do is we can decouple all of our assets from the SQL Server name. So right now you've got this big monolith SQL Server, you've got this big database or a bunch of databases, maybe 20 databases, and App 1 connects using the server name, maybe App 2 connects, maybe Excel and SSRS, all these different things are connecting to the database using its actual name. Well, when you move that server into Azure, that name is going to change. And all those things that are connecting to SQL Server, their connection strings are going to need to change also. But you can make that change now before the migration even starts. In fact, it's a really good idea to rename your SQL Server and see what breaks before the migration. That could be a very easy step to see what you actually need to change. So if you'd like to do that in an easy way, in a way that is more respectful to your users, the first thing that you should do is go into DNS and create an alias, a DNS CNAME for your SQL Server. And then once that CNAME exists, you can go into SSMS and test it. Did the CNAME work? Just go and connect, right? If the connection works, now go into Excel, SSIS, SSRS, all those different applications, your backup tool, link servers, anything you can think of from anything external to that SQL Server, and use that DNS alias everywhere you can think of it. And then as you do it, make a list of what you touched. You're cataloging everything, right? And then as a final step, change the name of the server. That's it. It won't take you very long. Once you change the name, you're going to get a very clear idea of what you broke. Quickly go into those places and change it to the DNS CNAME. Now what you have is a place where you can just update the CNAME after the migration, and you don't have to go through all those different places and figure out, how you're going to change it after the migration as some kind of like downtime exercise. Now you just change the DNS CNAME, and those things should connect just fine. Another thing you might consider, it's not a very good practice to be using three-part object names in your code. When I mean three-part object names, I mean the database name, the schema name, and the table name, or the store procedure name, or the view name. So those three-part, or even worse, four-part names in your code are not going to be supported in Azure. So you won't have the ability to use these three-part names. But now it's not exactly true. You can use these names if you're going to a VM, right? And you can use three-part names if you're going to a Azure SQL Database managed instance. But you can't use them if you're going to Azure SQL Database. So you may consider that this is technical debt. What you've done, think about it this way, right? When you're using three-part and four-part names, you're effectively coupling two databases with each other. And when you couple those two databases with each other, you can't move one or modify one without thoroughly testing the other one. So if there's a way for us to avoid doing this or to stop doing this, and maybe we do it by creating a data feed to import the data rather than use a three-part name, or maybe we take a look at the functionality and we don't really need it, right? If there's a way to remove that functionality, we should remove it and get rid of it, because we want to remove the tightly coupling, and then it'll make it much, much easier to migrate the database that we're trying to make independent, right? Another good example of technical debt is just databases that are too large for no good reason. And I know that the databases get large, and when you ask users like, hey, can I archive some data or delete some data, they all panic, right? They go into they hate the idea. And I ask users all the time, I said, what about this data from 10 years ago is going to teach you anything about your business today, right? Like, it's 2020, we're in the middle of a pandemic. What about business in 2018 would tell you how business is going to be today? Are our businesses even the same right now? No, they're not the same. And so I think it's totally appropriate to go in and delete some old data, get that data out of there. We don't need it. At the very least, even if they say, no, that data is necessary, we need it, put it into its own database, put it into an analytical database, or even move it off to CSVs or files or Parquet files. I'll talk about Parquet files in a video later. But the point is, these databases are much too large most of the time. And when you take a look at the query patterns of these databases, you'll see that the query pattern really only cares about the last 13 months. Like, very rarely do I see queries that even care about data older than 13 months. And they all have where clauses. They're all like, give me the sales for the last month, give me the sales for the last 3 months. They don't care about that old data. So here's some examples, a list of data that I think could be moved out of a database before you migrate. And this might take you some time. It might take you several weeks to move this old data out. But temp tables are a great example. I often see a bunch of temp tables that nobody's used for years that we could delete. I see temp tables that are sometimes larger than the actual tables in production, audit tables that are too big, indexes nobody's ever using, overlapping indexes. These things can all be removed out of a production database. So here's a query that I'm giving you in the slides that will help you find unused indexes. And if you see an unused index is a terrible thing, just get rid of it. You're using up space, you're slowing down your writes, so get rid of it. Almost worse than an unused index is a rarely used index, like an index that's only used a few times a week or something like that. Why is a rarely used index worse than an unused index? Because when they actually do use it, they'll load that thing into memory and they'll potentially kick out a valuable index out of memory. So getting rid of your rarely used indexes is a great practice. Never be afraid to delete an index. You can also find some overlapping indexes, meaning they're indexes that are effectively doing the same thing but for slightly different queries. It's in general a good idea to delete extra indexes if you have indexes that share a leading edge. A leading edge is an index where the first column is the same. So if the first column of two indexes are the same, think about which one of those you should delete, and then incorporate the functionality of the one you're deleting into the one that's remaining, and now you'll have an index that can service two queries or more than two queries. That's a really good best practice, right? Here's a query that will help you detect when indexes shared a leading edge. Filtered indexes have been around for a long time, and I still see that, there are people that they're not implementing them. But in my opinion, they are the greatest performance enhancement for SQL Server, and they're just rarely used. In fact, if you have a database that's been around for more than 3 years, you should consider adding filtered indexes to all of your indexes. What's a filtered index? It's just an index with a where clause. That's it. So why is that important? Well, remember, if we have like 5 years of data there, and I just told you that the query pattern probably doesn't care about anything more than 13 months, then add that filter to your indexes. And what you'll do is you'll take that great big index and you'll shrink it down significantly. And shrinking these indexes, 1, will make the database smaller and easier to migrate. 2, it'll use memory a little bit better. And 3, when you have to go to scan them, they'll scan faster. So you know that scans happen because of bad queries, right? So make smaller indexes and you'll scan much faster, and your queries will perform faster and your applications will perform faster. So not only will you make a database smaller, but you'll also make it faster. So you can do that right now before you even migrate. Let's take a look at that real quick. So I'm going to open up SSMS. And here is an index. This is the TBL books author ID index, right? And if I query TBL books, right, you can see that the query comes back. You know, how many rows are in it? About 20,000. How many rows higher than 11,400? About 1,000. So this index, this is a covering index. This author ID, it has author ID and price. So this will cover it, right? So if I right click and I go to properties, you can see that in fragmentation, how many leaf level rows do I have right now in that index? 20,000. But if I come here and I add a filter to my index, here's my create non-clustered index, right? Author ID, include price, that's how it's covering, right? And then where author ID greater than 11,400, and I run it, and then when I come back here and I look at the fragmentation, now the leaf level rows are 1,000. So I've significantly decreased the total number of rows in this index, and I've made it more efficient and easier to scan, easier to seek, probably, and easier to migrate. So yeah, it might be a lot of work to do this, but doing this for all of your indexes is an excellent practice. We can make the database smaller by defragging it and shrinking it. You know, a lot of us that have these great big databases, I've seen customers who have just stopped defragging. And they stopped defragging because they didn't introduce table partitioning, they didn't have multiple files and file groups, and so consequently, they just had these great big tables that took way too long to defrag. And remember, until SQL Server 2019, we didn't have resumable index operations. So they would take so long and it would end up giving them downtime or too much I/O or make everything slower that they just stopped doing it. And you know that's a bad practice. You know we have to introduce index defragmentation is, you know, at least monthly, right? If not more, depending on the amount of change that we're seeing in the database. So this is a query to help us figure out which tables really need to be defragmented. And I know a lot of us are using OLA script for index optimize. We should be implementing that. We should be implementing table partitioning. And we should, if we archive and if we shrink it down and we filter these indexes, then defragging should be a lot easier, right? We can also introduce compression. Page compression and column store indexing can be used to make things much, much smaller, right? Make the database smaller by getting the blobs out. So many of us have been storing binary large objects like files in our databases. And we've been doing that, I think, because it makes backup and restore a lot simpler because we have a low likelihood of orphaning records, right? But the problem with storing blobs in a database is, one, blobs are slow in a database, right? Unless you're using file table, blobs are really slow. So if you're using things like image, which we know is getting deprecated, or like varchar max can become a blob, right? If it's too large, you've got, or var binary max, right? That could become a blob, right? So when you've got these really large fields in there, you know that the indexing is going to be less efficient or non-existent. You know that you're going to balloon the size of the database, right? I've been into databases that have, you know, 1 million PDFs in it or images, right? So the data access is slow when you do that. So one thing you can do is you can remove, right now, with an on-premise database, you can take all of those blobs and you can put them in Azure Blob Storage. Now, Azure Blob Storage is meant for blobs, and it has some great advantages. You get a guaranteed 150 millisecond access time, no matter what, right? So it doesn't matter if you have a petabyte of blobs, you're always going to have 150 millisecond access time, which makes the data access out of blob storage much more predictable. And if you can use different options to even get faster than that, you can use CDNs and better storage to get faster than 150 milliseconds. And that scales no matter how many blobs you store. And the blob storage in Azure Blob Storage is really, really affordable. It's pennies on the gigabyte, a penny on the gigabyte. So you could store terabytes of data and not even notice the bill. One of the great things about Azure Blob Storage is you don't pay for compute. Remember, in an earlier video, we said that Azure charges you for network, disk, memory, and compute. And by far the most expensive thing is compute. But with Azure Blob Storage, you don't pay for compute. You only pay for the storage cost, which is usually pretty affordable, pretty cheap. So you go into your database, you write a little C# app. It won't take you that much time. Write a little C# app, grab the blobs out of there, move them over to Azure Blob Storage, and in return, save the URL to Azure Blob Storage. And then you're going to have to modify whatever application is pulling those blobs out of there to, instead of pulling them out of the database, you use that URL as a pointer and you pull the file out of blob storage. This can significantly reduce the size of these large databases. Removing these blobs, man, I've seen databases go from terabytes to gigabytes to megabytes. Really, it's significant. So once you get them into Azure Blob Storage, they're backed up automatically for you. They're saved automatically for you. They're fault tolerant for you automatically. There's some great benefits there. So it's really a good practice to do that. Get those blobs out of the database if you can. Find some bad actors on the network. So if, Entity Framework is famous for having the N+1 problem. The N+1 problem, very simply, is if Entity Framework needs to get a bunch of orders for customers, it will first get the customers and then one at a time get all of the orders. Now, Entity Framework can be configured to not do that, but some people just don't do it. And when you're local, with a local on-premise SQL Server and a local application and local Entity Framework, sometimes the N+1 problem can be hidden. But in the cloud, it's not going to get hidden. You're going to notice it. So you might as well solve it now. So take a look, use Wireshark or Fiddler or some networking tools, and use your application and see how many round trips are going to the database. Those round trips will tell you you've got to correct some code in the application before you're ready to migrate that thing to Azure. So you want to detect any of these bad actors. I once looked at a load screen for an application, and it took 700 round trips to get into the load screen finished. 700 round trips for the load screen to finish. That's ridiculous. It was just terrible code that needed to be corrected. Another thing that you can do right now is you can move your backup and restore process to Azure. Meaning right now you're backing up BAKs and TRN files, right? And those might be going local, but instead you can back up and restore those files, the BAKs and TRNs, into Azure Blob Storage. If you do that now your BAKs and TRNs are already in Azure. Think about how much easier it will be to migrate that database if you've already got those files up in Azure. So for instance, if you're going to an Azure virtual machine, you could restore those BAKs and TRNs into the Azure virtual machine, and boom, you're ready to migrate really, really quickly. If you think about it, you could even use it as some kind of method for log shipping, where you're keeping the Azure virtual machine consistent the entire time. Every time you back up a TRN and put it in Azure Blob Storage, you restore it in the in the virtual machine, and now your cutover time is much faster. You've got a much lower cutover time when you go to migrate and switch over to the VM, right? So consider doing that early. You may consider to upgrade your on-premise SQL Server to the latest version of SQL Server before the migration. Doing that will give you all kinds of benefits. For instance, you might get better compression, you'll get a better optimizer, you'll get new features that will help you shrink the database and pay off technical debt. So anything that you can do early like this is good. You know you've got to do an upgrade probably. It's probably an old version. Let's see if we can knock that out before we migrate. You might want to download some tools. We'll talk more about these tools later and I'll demonstrate these tools, but for now I'm giving you the links where you can take a look at these tools, see what they do, and figure out if you're ready to migrate. Now, this next topic is critically important. This is Azure ExpressRoute. Some of you may not have heard of ExpressRoute, but you really need to pay attention. This needs to be implemented. Typically, maybe 1 out of 10 customers will not need this, but 9 out of 10 of you will need this. ExpressRoute is a direct network connection between your on-premise data center and Azure. That direct connection is provided by a third party, meaning you're going to go to AT&T or Verizon or whoever your network connector provider is, your internet service provider is, and you're going to order an Azure ExpressRoute. And what's going to happen is they're going to drop a line from your network into Azure. And what that will do is 2 things. 1, it will increase your bandwidth into Azure. 2, it will also decrease the network latency into Azure. So your bandwidth will be like, oh, now you've got a 10 gigabit line from your on-premise data center into Azure. Your latency, so typical internet latency is 150 milliseconds. And if you don't have any connection, if it's just the public internet, what you'll probably do is use a VPN from your on-premise data center into Azure. And that VPN will slow down network connectivity and it will increase your latency, which is bad, right? So you might get 150 milliseconds, 180 milliseconds going into Azure. So if you go to move a whole bunch of data into there, the latency is going to kill you. It's going to be way too slow to do it. If you install ExpressRoute, you'll drop that 150 millisecond latency down to like 30 milliseconds or sometimes even less. I think I have a customer now that has like 12 millisecond latency into Azure right now. So really low, so much faster. And then when you get your 1 gigabit or 5 gigabit or 10 gigabit line, you could move that much more data from on-premise into Azure. Likely, you're going to need ExpressRoute even after the migration is over. So when you have your 1,000 users interacting with Azure, you're going to need ExpressRoute because those 1,000 users are going to want a low latency, high bandwidth environment. Here's the deal, you guys. Everybody underestimates how long this will take. When you talk to AT&T and you talk to Azure, they'll say things like, oh, it'll be done in 5 days. That is not true. It will not be done in 5 days. If you get ExpressRoute done from the time you order it till the time it's working and actually working in 5 days, I want you to tweet me. That'll be very, very impressive. On average, it takes about 5 weeks to get this done. I had one customer where it took 3 months to get this done. So this needs to be accounted for now. You need to start it right now. If nobody's installing ExpressRoute, you need to get this thing ordered right now. It's actually not that expensive. It can be affordable. One of my customers spends about $500 a month on ExpressRoute, which is not too bad. But of course, if you increase bandwidth or your ISP is particularly egregious, it can be several $1,000s a month. So, do it now, budget for it now, get this thing going now before you migrate. Another thing that you get with ExpressRoute, instead of just predictable performance, you also get security. as you migrate your data over ExpressRoute, it doesn't go over the public internet. It goes over your like MPLS network. So that security can be pretty advantageous. In fact, it could meet your audit requirements. You might have audit requirements that your data doesn't go over the public internet. So be aware of those requirements and make sure your data is going through the ExpressRoute. It can actually be cheaper. Remember that the cloud charges you for 4 things, right? Network, disk, CPU, and memory. Network is charged for ingress and egress fees. But if you use ExpressRoute, those fees are significantly lower. So ExpressRoute can really make that much more affordable. ExpressRoute can be for more than just Azure. For instance, in this diagram, you're seeing Office 365, Power BI, some machine learning processes, all sorts of different things can go over that ExpressRoute. So really, when you think about all the Microsoft services, like even Xbox Live, they're all hosted in Azure. And if you connect to the Microsoft network, you will use Microsoft bandwidth in between their data centers and in your data center for all the services that are being used by your organization. It can go down ExpressRoute. So ExpressRoute can benefit all of your Microsoft services. So be prepared for that and configure it for that. That can be significant. It can also improve Dynamics and like CRM Online, SharePoint Online. Those things are valuable. ADO, right? Azure DevOps, right? Can be benefited. So yeah, ExpressRoute can provide a much wider organizational benefit. It also gives you global connectivity to all of Microsoft's data centers. So Microsoft has these great big internet pipes, these connectivity pipes in between their data centers. Connecting into ExpressRoute into a data center gives you good throughput throughout all their data centers and lower latency through all their data centers. So remember, ExpressRoute takes a long time. Keep in mind, now, you know why it takes a long time? Because you're getting Microsoft, AT&T, and your organization to all talk to each other. And when something breaks, they will all point fingers at each other. Your network guys will point fingers at AT&T, who will point fingers at Microsoft. And then all of a sudden, you'll get them all on a phone call to say, hey, why is this thing still broken? And then finally, it'll start magically working, and nobody will fess up that it was them because nobody wants to take the blame for the delay. That's what's going to happen to you. I apologize, but getting these big companies to cooperate sometimes, it's not easy. Okay, with ExpressRoute out of the way, the next thing we need to take care of is Active Directory. So we need security in Azure. Now, we probably have local domain controllers, but somehow we need to get those domain controllers into Azure, so that when our SQL Server is in Azure, we have something local to do authentication, and we're not doing authentication over WAN links, right? So be sure to be thinking about how you're going to get Active Directory up there. I'm not an Active Directory expert. I rely on a Soliance partner, one of my teammates, Dan Patrick, or Chris Peachman, to do this for me. So consult with your security guys and say, hey, what are our options for getting Active Directory over there? And then, follow their best practices and get it up there first before the migration. Some things you need to know about Azure. So we're going to focus on migrating to a VM first. So let's just real quick tell a real quick story. So I got my MVP by writing an article comparing Azure, SQL Azure. At the time, Azure SQL Database was called SQL Azure, with Amazon Web Services, AWS, had a product called RDS, which is Relational Database Services. So I wrote, back when we had magazines, I know that's a long time ago, but in 2009, there was a widely read magazine called Developments Magazine for software developers. And I wrote an article comparing AWS RDS with SQL Azure right when it came out, which was now 11 years ago. And I noticed in that article that these two products that were competitors were built really different from each other. So AWS's first services, when it was brand new, were all IaaS. They were all VMs. So they had AWS S3 and AWS EC2, and those were the very first things that they released. And like I said, it was all IaaS services. Azure services were Azure App Service, what they originally called Web Service, and then Azure SQL Azure were their first services that they released. And those were all PaaS services, platform as a services. So Azure was really trying to be more multi-tenant, more cloudy, and AWS was largely being IaaS before they started overlapping each other like they do now. And it's they almost immediately started overlapping each other, right? So RDS was basically created kind of like you were using your own dedicated virtual machine that AWS just managed for you. So AWS would say, oh, do you want a SQL Server in RDS? Yes, I want a SQL Server. Okay, how many cores, how much memory, what version of SQL? And they would basically build you a SQL Server, and now it would work for you, right? Azure SQL Database was not like that. They didn't use cores like that. They used what they called, I think they called them database units or database transaction units, just like request units in Cosmos or something like that. I think they still did call it DTUs at the time. But anyway, database transaction units. And what you would do is you would say, I expect to use 100 DTUs, and you'd move the slider bar over to 100, and then you'd go create your database, and then you'd have a database with that many transactions a second. And if you needed more or less, you would just move the slider bar back and forth. So they had a much different idea about implementation. In Azure SQL Database, they had this one big, large database that kind of was multi-tenant that everybody kind of shared together. And in AWS, everybody basically got their own VM that was just managed. All the hard stuff about keeping the operating system and database up to date was all done by Amazon. So this is why we have Azure SQL Database Managed Instance. In my opinion, comparing Azure SQL Database with RDS is not a fair comparison. They're almost like two completely separate products. But Azure SQL Database Managed Instance, where you specify your cores and your memory, and now you've got basically a server that Microsoft manages for you, that is a direct competitor to RDS, and it's priced very similarly to RDS. So I just thought I'd throw that story in someplace so that you kind of knew the background of these products and how they were working with each other. And so that you also do some of the history. Azure virtual machines were released after their PaaS offerings, and we're going to talk about the virtual machines right now. So why are we even thinking about VMs? Like, PaaS is ideal, right? We want our application to be a PaaS application, and maybe you're thinking, I don't even need VMs, Ike. I mean, I know you're talking about VMs a lot right now, but I don't even want to use them. Fine, don't use them. But you're probably going to at least need 1 or 2 VMs. Why are we thinking about VMs? Well, even if you don't use a VM for SQL Server, even if you decide to migrate directly to managed instance, you'll still need the jump box for SSMS or Azure Data Studio. You'll still need a place where you can move data around in Azure without getting charged ingress or egress. So for instance, if you don't have ExpressRoute and you have your workstation here and you just use SSMS, you're going to get charged moving the data back and forth when you use SSMS. So you'd rather have the jump box where you're using RDP to get into the VM, and you've got SSMS installed there, and you query. Now you're not getting charged the ingress egress, you're just getting charged for the screen scraping, which is much slower. Much lower. It's much a lower amount of data, right? You're going to want to be interacting someplace where there's low latency. You're going to want a place like Azure SQL Database doesn't have SQL Server agent. So if you have SQL Server agent jobs, you might still want those things to be in a VM or SSRS or SSIS. Networking can be a challenge. You might want your SQL Server isolated on a virtual network where people can't use port 1433 and connect to it. So you're going to want a jump box so that you don't have to open up 1433 through some type of isolated network, right? Some people say that in a production environment, you shouldn't allow anybody to connect through 1433 except for the application itself and nothing else. So you'll want the jump box there to make that easier. And remember, with the jump box, you can pause it and not get billed for it, which can save you money. So you can start it up, use it when you need it, stop it, and not get billed. That's pretty neat. Okay. So another thing that we need to be doing early is thinking about disks. Remember that SQL is I/O bound, and I/O is incredibly important. Your local I/O is very likely, not guaranteed, but very likely to outperform Azure's I/O. So we need to plan our disks in an Azure VM very, very carefully. So remember, it's all about the disk, baby. So when we talk about disks, we're largely talking about two things. We're talking about IOPS, which is how many I/O operations per second we need. And we're talking about throughput, which is how much data is going through all of those I/Os per second. So you want high numbers for both things that are enough to cover your workload in SQL Server. So you've got this SQL database, you're about to move it to an Azure VM, and you need to sort out the disks and figure out what disks you're going to be using. Now, here's what I want you to remember. If you remember nothing else in this video, but you remember this, remember that your disks can be expensive. So your VM, let's say that your VM is $1,000 a month, your disks themselves can be $1,000 a month. So we want to plan the disk size and speed appropriately. So for instance, these are the different disk options you have. Some of them, there's more than this. I'm going to show you more. But as you go higher on the pricing for the disks, you get more IOPS and you get more throughput. So you want to make sure you're at the sweet spot where you're giving yourself the exact number of IOPS and throughput that you need, and you're not paying a lot. You can see in the pricing for 32 terabytes, 20,000 IOPS, 900 megs per second, it can be up to $3,000 a month, right? $3,276 a month. So they can get pretty expensive. By the way, this pricing here is for premium SSDs. I would highly recommend that you use SSDs for your disks in your virtual machines. You're going to need the IOPS. You probably don't want standard HDDs, right? You may need Ultra disks. Ultra disk can significantly increase your IOPS and your disk size and your throughput. So just be aware of Ultra disks. These are not available in all regions right now. So if you decide that you need Ultra disks, you really need to be sure that you pick the right region. Now this work is important because you're going to choose where your ExpressRoute goes to. So let's say that you know that the North Central US region doesn't have Ultra disks. You don't want your ExpressRoute, when you go order it, to go into North Central, right? You're going to want it in East US 2 or in a European region, right? Stay away from storage space. It won't really give you that much more IOPS for SQL Server, and it will tax the CPU, and it's expensive when it does that, so don't use it. There's a utility with a link here in the slides that you'll have that you can download Disk SPD. This will tell you, Disk SPD is a free utility that Microsoft created. You can run on your on-premise SQL Server right now, and it will tell you your IOPS and it will tell you your throughput. And that will be important as you go to recreate it in the VM. So what you'll do is you'll use Disk SPD to figure out IOPS and throughput on premise. Then you'll go build your disks in the VM and you'll run it again, and you'll see, were my assumptions about what I built correct? Did I get the IOPS and the throughput that I expected to get? And now there's some other disk recommendations here. I don't expect you to remember these, but they're in the slides for your future reference. But remember, you're probably going to use SSDs, right? You probably only want to use HDDs for dev and test, and even then you might not want to use it for dev and test. Keep your storage account and your VM in the same region. So remember, if ExpressRoute is going to East US2, make sure that your storage account where your disks are in East US2, and that your VM is there so that they're all together and you get really low latency and high performance. Disable geo-redundant storage. You don't need it for Azure VMs with SQL Server. And then you might consider using Azure disk striping for performance. Remember your disk best practices. Separate the log and the MDF files, right? Avoid using operating system disks for database storage or logging. Separate those out to their own things. Enable read caching for your data file and a TempDB file, but disable read caching for the log file because that's just a write-heavy sequential log. You don't need read caching for it, right? Like I said, consider striping, format with documented allocation sizes, place TempDB on a fast local D drive to get better performance. And there's some things that you need to watch out for in source systems, like when the log and data files are together, when they're greater than 2 terabytes. If you have more than 2 petabytes of disk storage, then you'll need to try to make that smaller, right? I don't know why it's that big, that's pretty huge, but try to break that smaller. If you can't get it any smaller, then you're going to need multiple SQL servers to handle it because Azure VMs won't handle 2 petabytes of data. If you have IOPS greater than 20,000, you're going to need to break out to several different disks probably, or if you have throughput greater than 900 megabits. So be aware of those requirements and plan your disks very, very carefully. Choose the right VM size. There are several different VM sizes. As you go up from B to F to E, they get significantly more expensive. Like the N series are GPUs and they're very expensive, but you might need that performance. So, figure out what your memory and CPU requirements are and start testing them. So I would, before you actually do a real migration, I would build the VM, build the disk, back up and restore over that VM and look at the performance and see if the performance is where you want it to be. And then finally, remember the importance of baselining. So this is a picture of Azure SQL Monitor, but you could use Idera or another competitor to Redgate. I prefer using Redgate, but everybody's got their own preferences. You should be baselining with Redgate your local on-premise server, and then in your Azure VM, install the same tool in Azure and make sure you're getting the same performance from both sides, right? That you're getting the same CPU utilization, the same memory, everything the same, so that you can more predictably be confident that when you do the migration, your users will get the same performance experience. All right, and with that, let's take a look at a tool called Data Migration Assistant. We're not going to actually do a migration right now, but we are going to do an assessment that will help us see if we've got other things to do before we do the migration. So this is Data Migration Assistant, and this tool can actually help you migrate your data into Azure if you'd like. But we're not going to use it to migrate. We're going to use it to assess. If you click the plus sign here, it says, would you like an assessment or a migration? And we'll say initial assessment. And we'll say, what's this assessment type? We're going to assess the database engine, although we could also do integration services. It's a SQL Server, not look at AWS RDSs here, but nope, we'll do SQL Server. And then where are we going? We can say SQL Server in an Azure VM or managed instance or an Azure SQL Database. We're going to choose an Azure SQL Database, and we're going to go ahead and create. Now it says, okay, we're going to check database compatibility and feature parity compared to where you are to where you're headed. I chose Azure SQL Database because it's more interesting and it will tell you more about the product. So let's click next. Now, my server name is localhost. I'll use Windows authentication and I'll connect. And we'll do the T-SQL version 5 database and we'll click add. And then, start the assessment. If it's a large database with a lot of objects, this will take a lot longer. So if you've got thousands of objects, this will take some time. And it says things like, hey, you've got some things you might want to fix here. You've got 3 unsupported features we think that you're using. For instance, Service Broker is not supported in Azure SQL Database. SQL Database does not support EKM or Azure Key Vault integration. SQL Database doesn't support analysis services. So that's pretty good, just 3. It didn't see any 3-part names or 4-part names. It didn't find, the CLR objects. It didn't find anything like that. But what you're going to do is you're going to run this assessment using Data Migration Assistant on your on-premise database, and you're going to get a report of the things that you might consider fixing before a migration. If you're going to a VM, it probably won't be that much, but if you're changing versions, it will tell you, oh, look, you're using things that might not work in your new version, right? So just be prepared for that. Anyway, I hope this has been helpful, and I hope you're able to use this tool to figure out what technical debt you have and to help you pay it down. All right, that's it for this video. Thanks for watching.